there are two differences. In chemical reactions, we have change of electrons or sharing of electrons, losing of electrons or
Yes, sir.
gaining of electrons. Okay, so can you write
Yes,
these
sir.
2 points? You write nuclear reactions, you give the heading, then you write the difference between chemical reactions and nuclear reactions. Number one, here you see the first line you write on your copy. Can you see
Sir,
the first line? What is written there?
sir, I just after you said that copy, I just আমি আমার কপিটা আনতে গিয়েছিলাম, আমি কিছু শুনিনি স্যার।
Okay. Look here. At the beginning, the first line is written chemical reactions result only in the transfer of electrons. Element remains same. Okay.
Yes, sir.
And from here, right. A nucleus reaction is a reaction that changes the mass of the nucleus. And after writing this, you give one comma, then write element is changed. Are you writing?
Yes, sir, I'm writing. Sir, so in simple words, chemical reaction is the transfer of electrons, and
Element
nuclear
remains same.
reaction is the change
Element
of
remains
nuclear
same.
mass.
This one also you should mention. Element remains same. Very
Yes, sir.
important.
And in a nuclear reaction, there is a change in mass of the nuclear.
Nucleus,
Yes, sir, nucleus.
comma, element is changed. So you got two differences, right? Here. And then you write this equation.
Sir, by the way, are you typing something on the...
No, I'm not typing. I'm not typing. I will just add here. You write this equation, huh? Then after writing, I will write something here. Then you add that part.
Okay, sir. Sir, after what I will write the equation. The
You
nuclear reaction is
write this equation, huh?
yes,
You finish this equation?
yes, I did.
Okay, okay, very good. Now,
No, sir, but after what I will write the equation.
okay, you finish the
After what?
equation. You finish the equation, then you write here. Is there alpha, right? In
Yes,
alpha,
sir.
in the bottom part, left side, you write 2, and the top part, left side, you write 4. That's it. Alpha has 2 protons and 2 neutrons, right? Hello, Karim.
Yes, sir.
Don't mute. You always be ready here. Alpha has 2 protons and 2 neutrons, right? Hello.
Yes, sir.
So here we are having for 2 protons, atomic number of alpha is 2 and the mass number of alpha is 4. And if you write this, then you can understand the left side and right side of the equation is matches, right? The mass number,
Yes,
atomic
sir.
number, these are matching. Now, can you please read from the beginning? Just have a reading
Yes, sir.
from here to till to the end. I hope you will understand everything now.
Okay, sir. Chemical reaction result only in the transfer of electrons. Element remain the same. But in nuclear reaction, the nucleus is the reacting element and the produced element are not same. The nuclear reaction is the reaction that changes the mass of the nucleus. Nuclear reaction occur both in nature and the nuclear reactor. In nuclear reactor, the standard nuclear reaction is the decay of uranium 235 RMM, the super heavy element in the periodic table. That is to say, those with the atomic number exceeding 83 undergo alpha decay to reduce number of proton and neutron in the nucleus of the atom. An example of alpha decay would be decaying of uranium 235 RMM into thorium 231 RMM. Element with a high uh, neutron to proton ratio undergo beta decay, in which uh, a neutron is changed into a proton and an electron as the entire processes take place into the nucleus of the atom, and the nucleus only certain protons and neutrons.
Content.
Oh, contain proton and nucleon. Okay. An entire process takes place in the nucleus of the atom, and the nucleus contain only proton and neutron. The electron that is generated is ejected from the nucleus as a beta particle.
Okay.
So that means I was right that a neutron is formed when a proton and electron goes under immense pressure in a star.
Yeah, this is because of we had discussion before. That is weak force, right? There is one force in the nucleus that is called weak force, which is always try, which is always trying to make the proton and neutron ratio balance. Okay, and because of this tendency of that weak force, we are having this beta decay. Okay, is it
Yes, sir.
clear?
Yes, sir.
It's for the weak force. You just remember this way, huh? This is a nuclear. Inside the nucleus, there is a force. It is weak force. So we have more forces, like we have a strong force for which the neutrons and protons can stay together inside the nucleus. That is strong force, which overcomes the electrostatic force. We have also electrostatic force over there, right? So strong force holds the protons and neutrons together inside the nucleus, and weak force balances the proton-neutron ratio. These two forces you got new in your life, right? Hello?
Yes, sir.
So you should remember them. Now, another example. Can you please go on with this example?
Sir, what was beta decay? Means the proton number
Electron,
increased from
electron,
90 to,
electron. Beta means electron.
yes, sir. The
So,
proton number moved from 92 to 93.
yeah, 92 to 93, how it comes? Because one neutron breaks down and creates one proton and one electron. Electron is beta.
Oh, yes, sir. Yes, sir, I remember.
So in this
Okay.
equation, you also write this equation, and here you write minus 1. At the bottom left, you write minus 1, and at the top, you write 0. So is it clear?
Yes, sir.
This is beta decay, then gamma decay. You can also write about gamma decay. Before writing, you should read it. Huh? Gamma decay. Can you read from here? Gamma decay.
Sir, 1 minute. I'm just writing. Yes, sir.
Yeah, continue. Read.
Gamma decay, unlike the other modes of radioactive decay, does not change the number of protons and neutrons in the nucleus of the atom. Instead, it lowers the atom's energy level by 1. An example of gamma decay of technetium,
Technetium.
so technetium, oh yes,
Yeah.
technetium 99M. What does that N means?
Okay, read. You read. Then you will get it. What is M?
Okay. Into technetium 99. Okay.
There is
Note
one
that
note.
the
There is one
yes,
note.
sir. M in the technetium 99 M stands for metastable. So what is metastable?
Go on. You will get it. I gave all
Metastable,
this
which is
for
a
you.
term of an atom in ion or atomic nucleus means that the atom is at an excited state. Sir, কিচ্ছু বুঝি না।
Okay. So this atom is at excited state. That means it has more energy level, and this one is related to binding energy. You know,
Sir, do you mean by
the
bonding?
yeah, the protons and neutrons, they are staying in a nucleus. They have binding energy. Okay, so when this binding energy uh, is increased for any reason, huh, then that time the
Sir, do
atoms,
they move up and down?
uh, it can be happened actually for some reasons. I will show you little bit, though it's actually more details available in A levels. We are not discussing the binding energy transformation in our fusion. When we'll discuss fusion, that time we have some discussions on this. I'm showing you a little bit here.
Sir, supernova causes due to
Wait. You
um
don't jump, huh? You be here. Okay.
no sir. Isn't supernova the explosion of a star?
Yes. Look here. The last, at last, where I kept the cursor. Can you see here
Sir, I can't see your cursor.
now?
Yes, I can see now.
Here. Okay. The combined mass of four hydrogen. Can you read it?
Yes, sir. The combined mass of four hydrogen nuclei is 6.693 into 10 to the power minus 27 kilograms. Uh, the mass of one helium nucleus is 6.645 into 10 to the power minus 2 kg. This means that there is a missing amount of mass equal 0.048 into 10 to the power 20 minus 27 kg. Yes, the missing mass is converted to energy, which uh, radiates away according to E is equal to mc square. This is seen happening in the sun.
Okay. It's you see the product and the given element, huh? The product and the source. These two has a mass defect or mass difference, right?
Yes, sir.
Isn't it? So because of this mass difference, we have some, you know, binding energy loss. Okay, and that energy is converted to, you see, that mass is converted to energy, and it is emitting as gamma radiation. So here, the product and the source, they both have mass 4, right? Mass number
Yes,
or
sir.
nucleon number is 4, but even after that we have a gap in, mass. That mass is actually the mass of the protons or mass of the neutrons. If you check here at the beginning, we gave, it's not here in nuclear atom. Look, the mass of neutron, 1.6749. into 10 to the minus 27. Mass of proton is 1.6726. Huh? So
Yes,
there
sir.
is little bit gap, right?
Yes, sir. A gap of
And and
23,
and for this
0.002.
gap, there is also some change or difference in mass of product and source, and this gap, mass gap, is converting to energy. Okay, this is called mass defect, and this mass defect is the reason for binding energy also. Okay, we will get more discussion in A levels about this one. Huh? Now
Yes, sir.
you just remember this one, uh, what we are discussing, that because of this mass defect we have this excited state. Huh?
Okay, sir.
Excited state of this technetium, because this state is not coming directly here. Before this there is another step. Before this we have another step, like in nuclear fission we will get one of the examples of it. Here, look, when one neutron is absorbed by uranium 235, then it's coming to 236. Huh?
Yes, sir.
Uranium 236 92. Now this uranium 236 is becoming unstable or metastable. Okay, then it breaks down to krypton and barium. Okay, here we got gamma radiation because technetium is still in technetium. Okay, that's why we are getting gamma radiation. But here we are getting from uranium, we are getting two different nuclei. So it is nuclear fission.
There might be reason for the fission
Yes, yes. So
because it just simply could have done that, break the neutron into proton and electron and made beta force or something like that.
yes.
It could have been possible, but what was the reason for the fission?
So here we get the conclusion: in gamma decay, number of protons and number of nucleons same. Yeah? Only we are having
Yes, sir.
gamma radiation. It's going from excited state to stable state. Is it clear?
Yes, sir.
Okay, done. Now we are going for nuclear fission.
Okay, sir. I'll try to understand.
Can you read this nuclear fission from here?
Yes, in nuclear fission, the nucleus of an atom breaks up into two lighter nucleus. The process may take place spontaneously in some cases or may be induced by the excitation of the nucleus with a variety of particles. Okay. In a nuclear fission, the nucleus of an atom breaks up into two lighter nuclei. The process may take spontaneously in some cases or may induced by the excitation of the nucleus with a variety of particles. Example, neutron, proton, deuteron. So what is deuteron? Sir, sir,
Wait, wait. You see, we have neutrons, protons, deuterons, or alpha particles.
Yes, what are those deuterons?
Alpha particles.
No, deuterons. Deuterons.
You see, it's alpha particles. Huh?
But sir, there is a comma.
There is a comma.
Yes, sir. So doesn't it says that example? Then it could be neutron, proton, deuteron, or alpha particle.
Okay, well, let us check it. Huh? Right
Okay,
now
sir.
we check deuterons. So you write it, huh? In your
The
copy.
nucleus of a deuterium atom consists of a proton. Sir, what is a deuterium atom? Because it says consisting of a proton and a neutron.
You know hydrogen.
Yes, sir.
Hydrogen has three isotopes.
Three isotopes.
Yeah. So one is hydrogen, another one is deuterium, another one is tritium. Will you write it now?
Yes, sir.
Okay, right. We will discuss it in nuclear fission, but if you want to write, write it down, no problem. One is 1H1, another one is 1H2, another one is 1H3. So this one is deuterium. Okay.
So 1H1 is the hydrogen we normally know,
Hmm.
and this is deuterium 2H1 and
Tritium. 1H3 is tritium. So in the first one, we don't have any neutron. Huh?
okay, sir.
Here we have
In
one
the
proton,
second
one
one we
neutron.
have what about tritium? Two
Two
neutron or two
neutrons.
proton?
Two neutrons. Proton is here, one. That's why it is isotope, right? Proton should be
Oh,
same. So done?
yes, sir.
Yes, continue now. Thank you for your questions.
Thank
MA
you, sir,
Karim.
for explaining them.
Yeah, continue please.
Yes, sir. Nuclear fission. Okay, that is nuclear fission. energy like
Here, from here, you
okay.
continue, huh?
In the
Or with
yes, sir. I
electron.
was just looking at the diagram, means the figure. In the fission process, a large quantity of energy is released. Radioactive products are formed, and several neutrons are emitted. These neutrons can induce fission in a nearby nucleus of fissionable material and release more neutrons that can repeat the sequence, causing a chain of reaction in which a large number of nuclei undergoes fission and an enormous amount of energy is released.
So in nuclear fission, in this example, we have one uranium 235, which one is absorbing one neutron, and
Why would it absorb a neutron when it already is stable?
it's not actually uh, is stable. We want to have energy from here. Okay, in nuclear fission, we are trying to get some energy by nuclear reactions. That's why from outside we are giving neutrons so
Means
that
does it absorb the neutron by itself, or we need
no
to
no
means with
we
an immense pressure need to throw at it, then it gets
we
absorbed?
make the we make the arrangement, okay, uh, get the the uranium 235 to absorb the neutron, okay, so that it can absorb and it can continue the
Do we need
nuclear
to
fission
learn that
process.
preparation now, or we will learn later on in future sometime?
Yeah, we will get it just after this. We will get it. Okay,
Okay, sir.
we will get it. So now we are having the main thing here. We are having two lighter element. Uranium is a heavier nucleus, and from here we are getting two lighter nuclei. Okay,
Yes, sir.
so from a bigger one we are getting to lighter. It is called nuclear fission. Is it clear? What is called nuclear fission?
Yes, sir.
From a bigger nucleus, we are getting two or more lighter nuclei. That is called nuclear fission. Now, the other things we got here, supplementary, those are saying that one neutron is absorbed by uranium 235. Then we are having this reaction started. We are getting two lighter elements, and we are having also beside this lighter elements we are having some neutrons, extra neutrons. How we are getting them we will explain just after this page, but this neutron we are getting extra from this reaction. Those extra neutrons are again working to start another uranium 235 to split. Okay,
Means we have, if we even have one whole block of uranium, means
yeah,
normally physical block,
yeah.
one neutron can just finish the whole reaction.
Yeah, so one is starting this one, then it is continued. Huh? That's why it is called chain reaction. This
Okay.
this reaction is called chain reaction. One after another is going on and going on. Okay, now we are having more details here. Look how we are getting the extra neutrons. We will understand it from here. Uranium 235 is absorbing one neutron,
Sir, you
and
are lapping.
yeah, uh, you see we are having
Sir, I
krypton.
can't understand, sir.
You see we have here krypton.
Sir, you are lapping.
Can you please rejoin?
Sir, you are lapping. Sir,
can
you
you
are lapping, sir.
can you rejoin?
Sir, you are lapping. Sir, now you're too fast.
Can you rejoin?
Sir, it is problem. Okay now, sir.
Okay, look, you see here krypton, huh?
Yes, sir.
Krypton 92 and
Yes, sir.
barium 141.
Yes, sir.
Okay, so 141 and 92, how much it is?
Sir, it is 233.
We have here 236, right?
Yes, sir.
So we have here gap of 3 nucleons, right?
Yes, sir.
And atomic number you see, or proton number you see, 36, 56. It's matching with 92.
Yes, sir.
So we have this gap in mass number 3. That is actually the gap of neutrons, right?
It might be, sir.
Why might be? Proton number is matching, right?
Number 56 plus 36 is it?
It is
Yes, sir. It is
92.
matching.
So the gap we are getting in mass number, that should be for neutron
The
number, right?
neutrons.
So we
Yes,
have
sir.
here these 3 extra neutrons to balance that. This three,
Sir, then why did it show that means in the above diagram that only one neutron is again released? Yes, sir. Sir,
they
you see only one neutron.
they only showed you one, but we have 2 more neutrons here. Look, one is here, another one is here. Hello, look, here is only one, right? Hello,
Yes, sir. I can hear you.
yeah, here is they are showing you only one, but actually there are 3. Here is one, another one. They already started their work. Is it clear now? We
Oh, means
should,
this one. This one is here just to explain us that after this reaction, this is released.
yeah, yeah.
Okay, sir.
Now we showed here the equation with uh, all the particles. All the particles means proton, nucleons, neutron, all the things are coming here, right? So that you can understand.
Yes, sir.
Now you write this equation. You do not need to draw, only write this. That neutron with 0, 1, it is absorbed by uranium 235, 92. Then you give arrow here. It's becoming unstable nucleus of uranium 236, 92. Then it's splitting to 2 new nuclei. One is barium, another one is krypton. Please do it. Plus 3 neutrons.
So, sir, I will write that when neutron, then I in bracket I wrote n means 1n0,
Yes,
bracket
yes.
close, is absorbed by the uranium 235, and like neutron which I wrote in bracket I wrote uranium as well. Then after that, what should I write? That it become unstable and
Yeah, it's you give here uranium 236, 92 and just write here unstable nucleus. Done, Karim?
Sir, I'm just after splitting. I am on that. Means I'm writing in details.
Okay.
Sir,
Yes,
sir, these three nucleus, what material means? What do we call those material which can start a fusion? Means sorry, a fission.
this is actually we say these neutrons as fissile neutron that has some energy, kinetic energy, which can be absorbed by uranium nucleus.
No, sir, that was not my question. My question was like in an above paragraph, I think I heard a word fusionic material.
What material?
Fusionic, I think I heard it.
Fissile fissile neutrons.
Mm,
Well, there is one
yes, sir.
written fissionable material.
Yes, sir. This was which I was having.
Now you got it.
Yes, sir. And I'm still writing. And sir, what are these neutrons called?
Wait.
Sir, I'm in my last line that does fission create a large amount of energy or a small amount of energy?
Large, large.
Is it greater than fusion?
No,
Okay, sir.
but it's greater than other power stations.
So I can write like fission creates a large amount of energy, but not large enough as fusion.
Mhm.
Yes, sir. Done.
Okay, now we are actually uh, learning something more, huh? Now,
Yes, sir.
here, this chain reaction we are having here. You see, we have three neutrons. Those are also taking part in another three uranium to split, right?
Yes, sir.
So this way, it will be one uncontrolled chain reaction. Okay, and this
Yes,
uncontrolled
sir.
chain reaction can cause massive destruction. Okay,
Yes, because they are creating a large amount of
and
energy.
it's only we are doing in atomic bomb. Huh? Otherwise, what we do, we control this chain reaction. In nuclear
How,
power
sir?
station, power station, we control this chain reaction by using
Limited number of
moderators.
uranium.
Yeah, we control it by controlling the number of neutrons which are absorbed by the uranium, and also we can control it by the uranium we are giving there. There is uranium core, okay, or uranium rod is there.
Uranium 4.
Uranium
Oh,
core
uranium
CO,
core.
yeah, or uranium rod. The fuel is uranium over there, so that uranium we can also control. But
Means just giving a limited number of uranium.
yeah, we are showing that one. So you understand that normally it is uncontrolled chain reaction. In power station, we do control chain reaction. This is one thing, and another thing I'm showing you here. That is, you got one equation here. That one is creating barium and krypton, huh?
Yes, sir.
But it's always not like that. It will only create barium and krypton. Uranium, it can also split into rubidium, cesium. Okay,
Means
and
they can transform into four of them. Or
yeah, uranium can also be xenon and strontium. Okay,
sir, I have a question. What is the means? What is the smallest means the like in proton and neutron number? মানে total যেমন কি can this happen that uranium breaks and transforms into like magnesium and something or sodium and something,
it's
chlorine and something, carbon
not
and something. Means that small
sodium,
amount.
magnesium, sodium. They are not that heavier atom. Okay, and normally what
No, means I'm
happens?
just telling that.
Uranium, yeah, uranium. What is doing is trying to split in a way that it's creating uh, more closer, like its mass number is 236, so it will create another element of mass number 137, not like sodium, magnesium is small mass number. Okay, so you see they are closer. Huh? Strontium, xenon 144, rubidium is 96, cesium is 137. So it's splitting into
More
two
than
parts.
80,
Yeah,
more
it's
than 80
splitting
mass.
into yeah, it's splitting into two parts. That's it. Huh? So what idea I want to give you that it varies, right? It's not
Sir,
only
so can this be a note that when uranium breaks down,
you do not take
it
you do not need to take these notes because it's not that important thing for to understand nuclear. You in nuclear fission, we are having lighter nuclei from bigger nucleus. That's enough. Okay, but other things I am giving you why so that you can have a holistic idea about the nuclear
okay,
fission,
sir.
so that you can get interest
And
about
sir, one
this.
more thing,
Yeah.
like we can do fission of many other elements, isn't it? Rather than uranium.
Yes, we can also have for plutonium.
So I'm asking, what is the minimum mass number that we can do fission of? Means which element?
Normally, whatever I saw that uranium, plutonium, these two are mainly used for nuclear fission.
No, sir. I'm just talking that what is the possibility? Means till which possibility can we go? Means the least number
It's
of
not
mass
actually only about mass number. It's about some other issues like
about
about
radioactivity.
who can do this chain reaction, and who can also produce energy, more thermal energy, because our target is to produce thermal energy, right? Isn't it?
Yes, sir.
So who are more suitable for this one? That one is our concern. So many things,
Sir,
many
then,
issues, and
sir,
also
as you said that we do fission which is suitable for us, creates maximum energy with a
yes,
chain reaction. Sir,
not
so
only
in
that, not
yeah,
only that, not only that, we also should have them available, like we are
means
taking one,
according to their availability.
yes, availability, and also
Availability.
for expense. Many things we are considering over there. Okay, not only a single thing, not only a single parameter. So what we are going to discuss now, that this uncontrolled chain reaction, how can we control?
Yes, sir. But sir, my question was that, yeah, means can we do fission of? I don't need the chain reaction. Mean, can we do fission of an any element? Means the what is the
No,
least mass number?
no,
I just want to know that, sir.
I actually uh, cannot say you that way now. That what is the minimum mass number? Only we can understand that, or we have the information
I
that
understand, sir.
yeah, uranium and plutonium, they are used for mainly for nuclear fission. Okay. Now, uncontrolled chain reaction, how to make it control? Look, here is the power station, nuclear reactor. We have here control rods, control rods, and here is F, F for uranium fuel rods, and then we have M,
Sir, can
yeah,
sir,
M
you
for
were a bit lapping. Can you start again?
yeah. Look, we have here control rods.
Yes, sir.
We have here F for fuel rods.
Fuel rod.
Yeah,
Okay.
fuel
Means
rods means
they insert uranium through this fuel rod.
no. This one is uranium rod. Fuel rod
Oh,
means
understand, sir.
uranium rod. Here, uranium is the fuel. Okay, then moderator. We have moderator made from graphite. Okay,
Why graphite?
okay, we are going to discuss that one. Why it is graphite? So here, can you read this part?
Yes, sir.
A
A
moderator.
moderator slows the fast neutron down and make fission possible. Control rod help in adjusting neutron flux. Flux, sir, what is flux?
Density of neutrons.
Okay, which is turn effect power output. The basic function of this rod is to absorb neutron while starting a reactor. Control rods are pulled out so that the power output increases and reaches the desired level. Okay, so fuel rod are mane, we just input that much level of fuel rod inside the nuclear reactor. How much energy do we need according to that?
Yes, yes. So control rod is doing it, huh?
Okay,
And
and the
moderator,
moderator is to means slow the fast neutron means when we have already reached the limit, the amount of energy we needed, we can just absorb the neutron with the help of moderator and
yeah,
stop the
look,
reaction.
if we have the neutrons with very fast speed
Yes, sir.
is too much, then that will not take part in, absorbing. Uranium cannot absorb that one. We need a specific speed, uh, a specific speed of the neutrons so that it can be absorbed by uranium. Is it
Okay.
clear? This moderator is slowing down the neutrons. How? Why we are
So
using graphite?
neutron, where does neutron gain that energy to? Is it that energy which is being produced during fusion? Oh, sorry, fission.
No, actually the neutrons, that one also we are getting, but at the beginning we are giving, right?
Okay, sir.
That one we should, use graphite to slow them down, right? So that they
Yes,
can
sir.
reach a specific speed. Then we have coolants, huh? Here, can you read from here the heat?
Yes, sir. The heat released by fission in nuclear reactor must be captured and transferred for use in electricity generation. To this end, reactor use coolant that remove heat from the core where the fuel is processed and carry it to electrical generator. Coolant also serve to maintain manageable pressure within the core. Sir, I
Yeah,
didn't understand the coolant part.
coolants means we are giving water, huh? Coolant, the water is working here as coolant, and if you are giving water over there, what will happen because of this energy, heat energy? This will become vapor, right?
Yeah, something like that.
It
Or it
will,
might just, I
in
mean, are
nuclear.
we releasing the water inside the nuclear reactor or we are moving it through pipes?
Yeah, we are moving it through the pipes, and the temperature of this nuclear reactor is around 6,000 degrees Celsius.
Okay, means it can also melt the magnesium oxide.
So if it is 6,000 degrees Celsius, then what will happen? water will become steam, right?
Yes, sir.
High energy
100
steam.
times the degree we can tolerate.
Yeah, so it will become high energy steam over there, and this high energy steam will go through this part. Some of the water, uh, you see,
Will
here
cool
is,
down and come back.
yeah, this some of the vapor will be, condensed and come back to water again, and most of the vapor will go here, huh? Steam turbine. Is it clear?
Okay. So the steam turbine is way huge than the nuclear reactor, or it is smaller than nuclear reactor.
Steam turbine,
How could
I
it be,
think,
big it be?
okay, we see
Means how
the,
much big could it be?
I think, according to my knowledge, here we actually don't need, like, uh, if you think in our classroom, huh? In our classroom, class 9, huh? It's a
Yes,
big
sir.
class, and the teacher is sitting in one corner, and the whole classroom is there. So, a small amount of uranium is enough to produce huge amount of energy. Okay, so this one, the nuclear main chamber, huh, where the reaction is happening, is not that big, but it's, other things to maintain it, or to, do other processes, is becoming bigger, right? For the coolants, or for, you know having the shielding, huh? Shielding around it, so that the radioactive emissions are not coming out, not harming the people. And for some other things, like it is uncontrolled chain reaction, right? So for safety, we are making the surroundings. There are some safety measures is taken. That's why nuclear power station, it looks like big. But the main chamber for where there is nuclear reactor is not that big. Is it clear now? Hello?
Fair enough, sir.
Okay. So here we are making this infrastructure bigger, huh? Very big. But main chamber
So
where the
that it
nuclear,
can withhold the temperature.
yeah. So that we can have this, coolant. This part is shown very small, but this part is very big. Okay. It's only schematic diagram, right?
Yes, so
Schematic
just to
from,
give us an
yeah,
idea about it.
yeah. So steam turbine, it can be also a big one, even bigger than this part. Is it clear?
It surely would be.
And it's not only a single turbine. There might be multiple turbines over there, and they are showing you only one line here for steam to come. But
There could be multiple lines.
there might be hundreds of lines to go through the steam turbine. Is it clear?
Yes,
So you can imagine now how bigger it is. So you got it now,
yes, sir.
Karim?
Yes, sir.
Because we are having lots of energy, so we have to utilize that energy. If you are only using only one small turbine, it's not enough. We can use hundreds of turbines over there.
Mean
Okay.
maximum energy with minimum cost.
Yeah, yeah, correct. So you got at least some ideas, right? And
Yes, sir.
thank you so much for your questioning. Okay, I like your
Uh,
questioning.
and thank you for answering, sir,
So you
and
you
explaining.
please You please here mention some of the things. It's very important. Uh, at least you write here
Sir, won't we
one
do
thing.
fusion?
One thing
Oh,
you,
sorry, we are still in fission. I just
yeah,
marketing
fission fission is already done, and you wrote the equation about
Oh, we are
fusion
over with
fission.
fission.
Fission. We are in fission. So one thing you write here, uh, the the uncontrolled chain reaction can be controlled using moderator
Moderators.
and control rods.
Should moderator only be created with graphite, or we can use something else?
Moderators, we are normally using graphite. We are using graphite. I did not see any other moderators.
Okay, sir.
Okay. So you wrote that heading that uncontrolled chain reaction can be controlled by using moderator and control rods. And you also write a little bit about moderator, control rods, and coolants. Huh? You give moderator description this sentence, then control rods this sentence, huh? Then coolants, so that you can have some notes which you can recall later easily.
Done, sir.
Yes. You also wrote about coolants, right?
Not yet, sir.
Yeah, also write about coolants here, here, from here to this end.
Sir, what should I write?
Yeah, you should write reactors use coolants that remove heat from the core, okay, where the fuel is processed and carry it to
Sir,
electric.
can you be a bit slower because I'm just writing
From
what you
here,
just said.
you just write from here, from the notes. You write from here, reactors use coolants. Till here, generators.
Done, sir.
Okay, now we are
Sir, what is that? Coolant also serve to maintain
not
manageable pressure within the
not
core.
necessary. That one not
Uh,
necessary. Okay, it's also available in your notes. Just we
But
had the
sir, what
idea.
if it came to the exam?
It will not come in exam. In exam, you will get only what is
Sir,
called
you are again
fission.
laughing.
In exam, you will get only fission. What is called fission? That's it. And what is the use of control rods? Moderators.
No, sir. Like in two of the classes, the teachers once mentioned that uh, we never expected that O level would give this question, but they did. So that is the reason I was asking.
No, they will
Like in
not give it.
computer, Musa sir said that we didn't expect the means to give such a simple one, but most of the students lost marks in it. Means it was simple, but they thought that they would only get the critical one or this one, so they don't prepare. They were not prepared for that.
It will not come. It will not come. If it is coming, then you can answer. No problem. It's in our notes. You do not need to write everything. Okay, look here. Can you see how many learning outcomes are done?
Yes, sir. Describe the detection of alpha particle beta A is
That
done.
means A,
State
B,
and
C,
explain the
D,
random emission.
E, F,
Mm,
G done, right?
explain the process of fusion of fusion. So we are not done with fusion.
We are not done with fusion, but we are done with fission, right?
Yes, sir.
And G
Sir, what
also.
was radioactive decay again? Wasn't it that slowly the alpha, beta, and gamma particle will be
Yes,
lost?
yes, yes. That is.
Yeah.
Look here, G.
Means I need to
G.
just keep recalling those things, or else I will forget.
Yeah, G is also done, right?
Forget.
G.
Describe with the aid of block diagram one type of fission reactor. Or yes, sir. G is also done.
Okay, good. Now we are going to have discussion on this H.
H
H and F. That fusion. We
are
will do together.
interrelated.
Yeah, we will do together. And fusion and star formation will do together now. Okay. So can you read here H again?
Yes, sir.
Discuss the.
Discuss theories to star formation and their energy production by fusion.
Okay, that one we are going to do now. So here we are not getting actually too much or more elaborate questions, elaborate discussions for star formation. Only we are having
Sir,
the
you are
idea.
again lapping.
Yeah, we are only having the idea that in star we are having fusion. Okay, the energy from star we are getting by fusion.
Sir,
Yes,
sir, could you again say that because star formation because of fusion? Until this,
yes,
I didn't hear a thing because you were lapping.
yeah. In star formation, that one we are not getting any detailed questions from past papers. Only we are having the idea that in star we have fusion. Fusion is the source of energy in the stars. And sun, our sun is one of the stars, right?
Yes, sir.
And
The thing
we are
which
we
glows
are
and give
getting
off
the
light
we
due
are
to reactions is
and
fusion.
our energy source is the sun, right? Light energy, heat energy, and all the
Yes, sir.
energies in our earth.
They give off
That is,
photons.
yeah, that is the main source of energy of our earth. So we are learning from here that this energy is coming from the fusion process. This is our main concern. Okay, is it clear? And what are the conditions necessary to have fusion process? That one we will try to understand little bit. The other things I gave here, these are extra to get little bit idea life of stars, what is supernova, all these things I'm giving you extra. Okay, can you read life of
so that
stars?
I can keep those in mind, and if came in question, I can
Yeah,
answer.
yeah. Continue. Life of stars.
Yes, life of stars. The birth of a star begins when massive cloud of dust and gas starts to collapse and break down. How does this happen? It happens through the force of gravity. Gravity bonds the element together to create a protostar. What is protostar, sir? Okay, I think it
Continue.
will be future. Yes,
Continue.
sir. The protostar is basically a baby star. Sir, does proto in Latin or any other language means baby?
Yes, yes, like that. Okay, continue.
And grows into a star through its life cycle in the same way we are born and grow. How does
Yes,
it get feel?
continue.
The main process of all stars' birth is called nuclear fusion. The nuclear fusion happens is very large cloud on gas called nebula. When nuclear fusion starts in a nebula and reaches a temperature of 10,000 degree, the stars begins to form. The new baby star that, as we know now, is called a protostar. Gravity continues to play a part in the star's birth and continued life cycle. The mass of the star determines the color of the star, which allows scientists to categorize the type of star. Scientists can then allow, try, and confirm the amount of energy the star can give off.
Okay, so here the presentation I gave in a way so that the questions you will ask me, I also gave the answer of them. You might ask me,
Sir, it was like
yeah,
PowerPoint
listen,
presentation with sound was going on, and I
listen,
was listening to my
listen,
presentation.
listen. It happens through the force of gravity. Then might be there, you might have some question how it is happening by gravity. Then I
Sir,
gave
my first question was, how does
protester.
gravity form? Means how does it starts to form? Means gravity means it pulls the things.
Yeah, that's why I gave you here some idea. Gravity bounds the elements together. That means gravity means what? The pull, right? Pulling of the all the masses to each other. That is called gravity. Like all the masses, they are attracting each other. Okay, that is called gravity, isn't it? Hello,
Uh,
hello.
I think I still don't understand, sir.
So gravity means the pull of attraction, pull or attraction of all the masses. Like your table
My
and
one simple question, sir.
yeah,
Sir, where did the pull start from? Means I know that it is a pull of mass, means it is pulling the mass towards itself. But
yes,
how did the gravity started to form? Because it is not like that someone placed a vacuum or something like happened, a reaction happened for which some sort of vacuum starts to form and it starts to create pull the mass, something like that.
okay, very good questions. Now, uh, actually, if you want to have this discussion, we need only for this gravity, we need hours and hours. Okay, so we cannot finish this topic by many of the classes, isn't it, Karim?
Yes,
Hello.
sir.
Now, at least we can get idea that there is some condition working over there, like they said, massive clouds of dust and gas starts to collapse and break down. Okay, and how it is happening? Due to their attraction to each other. That is called gravity. Is it clear? Hello, little bit clear.
Yes, sir.
Okay, now you might ask me what is called protostar. Then I gave you some ideas what is called protostar, right?
Yes, sir. Baby star.
Baby star. So after baby star, protostar, we got here one thing that you have to remember these things. When nuclear fission starts, the temperature, we need a specific temperature, 10,000 degrees Celsius, for the stars to begins to form, right? So for starting the star or beginning of the star, we need a specific temperature, right? 10,000 degrees Celsius. Okay, then we need gravity, the force of gravity to bounce the elements together. Okay, these two things you remember. Is it clear?
Yes, sir.
Hello? So these two things you note down uh, for taking birth of a star. We need force of gravity which bounds the elements together, to create a protostar. And then when nuclear fission starts, then temperature should be 10,000 degrees Celsius. Temperature should be 10,000 degrees Celsius. So other things are extra. Okay, these two things are most important here. Now continue from here.
Yes, sir.
Karim, yeah.
Yes, sir. Let us look into the life of a star and the stages star goes through until death. These things are called life cycle and supernova. Life cycle is equal to life of a star. Supernova is equal to death of a star. Okay. Stars do not live forever. They live and die just like us. Although after its birth, the star lives for a very long time before its death. The type of mass of a star will determine how long the star will live for through its life cycle before the star goes supernova.
Okay, very good. You got here two things. One is life cycle, that is life of a star, the whole life of a star, and you got another thing that is supernova. Already you told me that it's explosion, right, at the beginning. Hello, Karim.
Yes, sir.
So by supernova, by this explosion, that is the end of the star, right? Death of a star. So you got the idea that at the last stage of the star we have supernova, right? Isn't it?
Yes, sir.
Okay, so I had planned actually today to go at least fusion, complete the fusion before half life, but we couldn't do it. We have little bit left. We have here life cycle, then supernova, then nuclear fusion. So with life cycle and supernova, you go fast, huh? You read this life cycle quickly, huh? Karim,
Yes, sir.
life cycle,
The
quick.
nuclear fusion, the star is born, and what happens through the star's life depends on the size of the star when made. What we know happens to all stars is that when the hydrogen gas runs out, which causes the star at its core to collapse, the star starts to use helium gas and other elements.
Yeah, the next.
The star becomes larger and larger over time and then burns out all its energy, leaving just the core. The star is still alive and is still very hot. Over millions of years, the star cools down, again depending on the type and mass of the star. The star can go supernova and die in a Big Bang explosion when the core is torn up, or can go very cold and stop to burn any energy. Sir,
Yes, yes.
uh, স্যার আমি ঠিক এইখান থেকে এই পর্যন্ত ওরকম ভাবে কিছু বুঝিনি।
It's going over your head, right?
Yes, sir.
So you need
Astronomy is really bad.
yeah, you you are asking, mashallah, lots of questions, and I am trying to give your answers as much as possible. So it's taking time, huh, for this explanation and also your questioning. No problem. We go with this one again. Depending on the type and mass of the star can go supernova and die in a big explosion where the core is torn apart. So two things here. Size, one is type and mass of the star. At the beginning, we got here one thing. Look, the mass of the star determines the color of the star. Huh?
Yes, sir.
So, color of the star, even our planets, different planets, they have different color, right? You know it? Mars is red,
Yes, sir.
and about stars, uh, that is also different color. Huh? We are getting different color. Color
Sir,
depends on what?
does that means that star have different various color like blue, pink, red,
Yes. So why this color is
yellow,
coming? Why
green?
this color is coming? Is depending on the energy they are radiating. Okay, the color depends on that
Um,
one.
means
Like
like how? Like if
like
they are using hydrogen, they are producing
you
like
know.
blue, then helium, then green, something like that. Means what
Yes,
type
yes,
of
yes. That is called what?
so
Spectroscopy,
sir,
right?
then we can say that, sir, then can we say that according to the color, we can say that what age it is according to the size and the color?
Yes, yes. We can have lots of idea on the color. That that's why I told you there is lots of discussions here. Okay, if we discuss it, then it will take hours and hours. So here I came back for you give you some idea that the mass of the star determines the color of the star, which allows the scientists categorize the type of stars, right? So we go back to our that discussion. The one you said is going over your head. Again, depending on the type and mass of the star can go supernova and die in a big explosion where the core is torn apart. So here our concern is supernova is the last, okay, is the death moment of the star, and it depends on the mass. It depends on the type of stars, right? And it will go for supernova, how long it will take for supernova, That one depends on the mass of the star, color of the star, and many other issues like size of the star. Just you have in your mind this information. That's it. We do not need too much information over here. So is it clear, Karim?
Yes, sir.
So this much you only have
Yes,
in
sir.
your mind that there are different types of stars, and depending on their types, their time of supernova is different. Okay, now
Okay, sir. Sir,
supernova.
does that also means that if they are more aged than the sir, moreover, does all supernova has the same force or the effect means according to their
Oh no,
size
no, 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 no. It also
or
varies. Yeah.
according to their or sir, according to their size, does means the time varies that
Listen, it
when the
depends on.
supernova will take place.
It's not only size. It's depending on many things, many issues. Okay. Their mostly their gravity. Okay, mostly their gravity, their energy available inside them. Okay, that is the main thing.
Sir, how does the supernova take place? Like, is it like that? Means the star
Yeah,
is just
read,
like
read,
that.
read,
It
read
is time
about.
to supernova,
It is
and
supernova. It is supernova. Read it.
okay, sir. Supernova are extraordinary event altogether and have even been witnessed and recorded by scientists. As there are so many stars in our galaxy, the supernova are common. So if the star does not quite die out, the star will die a very violent death by a way of supernova. What did they mean by die out?
Die out means quietly die out means it's silently.
It's a silent supernova,
Yeah.
or is
So
it like
yeah,
it is
like
just run out of energy?
some
So
of the supernova is not that much violent. Okay. Some of them are, quietly die out. The star will die a
and
very
some are really
violent death by
offensive,
the supernova. Huh?
and some are really offensive.
Yeah. Now,
Sir, this was not my question.
yeah.
Like, how does a supernova take place? Like, uh, let me explain with the annotation. Yes, sir. Like, this is our star. Like, when the supernova is taking place, will it just explode like this? Or, yeah, this one. Or it will, or it will be like, it just collapsed a bit. Means this is our star, which is just gonna supernova. It collapsed and then boom. Means
Actually, what is
is it like
happening?
it just collapses a bit and then due to the pressure it gives a much more effect?
No, not like the collapse one. The first one you showed is more likely that one. Okay. It's not like collapsing.
Like where it is, it just explodes from there.
Yeah, explodes from there, and there will be, a flash of light. Huh? Huge flash of light is coming from there during the death. Okay, that's called supernova. So,
Okay, sir.
you know,
And
this
sir, for any reason I think I cannot just remove the annotation.
no problem, no problem. Look here, we have some links here. Huh? If you are interested and
Yes,
you
sir.
have some, you can manage some time. I hope that your interest will continue. I gave here some link. Yeah, the whole paper I gave you some links. So I think you will find those links, YouTube links. Uh,
Yes, sir, I would
yeah,
really check them out.
those 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 you will find some more information, and you can share with me from there. Okay, if you have anything to know. Now we are
Okay, sir.
concluding here. Huh? It's already 9:09. you have to stop here, huh? Thank you.
Okay,
Thank you
sir.
so much for joining and your discussion, your queries. So what I expected from you that you are going through the worksheet. Are you doing that?
Yes, sir, I'm going through. And
So,
something like not 40%, something like 50% is left.
okay, very good. Now,
Means from what I have done till
yeah,
now. Like
after
I have only
after
reached till question 4.
yeah, after today's discussion, I think you can have some
There will
more
be more questions
questions.
I can do.
Yeah, more questions you can do. You already have the idea about nuclear fission. There are
Yes,
many
sir.
questions regarding nuclear fissions. So you can,
One more thing, sir. Can you go to the means the learning outcome?
yes. It's a big topic. Look, lots of pages.
Yes, sir.
17 pages. Yeah, yeah.
And sorry for the annotation. I don't know why is it going. Yes,
Okay,
sir.
I can remove all the annotations. Yeah,
Thank you, sir.
yeah.
And I will do a bit more of work. Means if you just can explain me a bit, then it would be easier for me to do the worksheet.
No, no, no. It's a big thing.
As much as I have make an idea
No,
that
we need time.
uh,
For understanding Half-Life, we
no,
need
sir.
a lot of discussion.
Uh, just one small thing that does halftime if a radioactive particle has a halftime of 5 years, then yes, sir. So would it
You
be
will
like
understand.
every
Listen,
5 year
listen.
the
Listen, you will
like
understand
if we
everything.
have X this year? So just 1 minute, then I can understand, means make you understand and say that is it correct or not.
Which one?
Like if this is X, yes, sir. I'm just saying, like half life is given that every 5 year. So if I have X amount of radioactive particles, so would it be X divided by 2 after 5 years, and then X divided by 4 after 5 years? Would it be something like this,
Yes,
or
yes,
would it
it's like
be?
that. It will be like that. The one you said.
That means every half lifetime, the it would be measured from the current one, or like
From the current
after
one.
5 years we okay, sir, I understand.
Okay. In next class, we will try to finish, huh? Finish
Okay,
this
sir.
topic. Inshallah. Okay, Allah
Inshallah, we will do it,
Hafiz.
sir. Assalamu alaikum, sir.
Inshallah.